Hello, and welcome to my final project for LIS 4761. I will be analyzing Airbnb listings with association rules mining and a Shiny application. My objectives are, firstly, to find insights about the pricing of Airbnb listings. Is it a large number of variables that are affecting and corresponding to high or low prices, or is it much simpler and only really comes down to one variable like location? So we will answer that question. Secondly, I will visualize these relationships interactively, which is specifically important to me because I had trouble somewhat with the Titanic association rules mining assignment, as far as finding the right sweet spot between support and confidence to generate the best set of rules. So I think setting this up interactively will make it easier to find that sweet spot and will be useful to the viewer as well. These two pieces should allow me to make a conclusion. The methods I'll be using to achieve these objectives come from Lesson 7, Association Rules Mining, and Lesson 9, Shiny Applications. I'll use these methods on data I discovered on Kaggle, which was originally sourced from inside Airbnb. It's nearly 50,000 observations and has 16 variables, so this is a pretty rich set of data that I'll be working with, especially considering how it's only specific to New York City in 2019. So now that I have the data imported, the first step I'll take is to update the column names to make it easier to interpret the rule set and also just for ease of typing. The second step, I will change the last review column to a date type from a factor. And thirdly, evaluate where NA values exist and see what steps need to be taken. I discovered that it's only present in two columns, the last review and the average number of monthly reviews. Instead of removing those rows, I gave these two columns defaults for NA values. That way those records can still be kept and analyzed, since those NAs are not very critical to the record as a whole. The last step I made was to change the last review column from date to numerical. So instead of reading as the date since the last review, it will read as the number of days since the last review and make it easier to analyze with this process. With the data cleaned, I'll move on to some preliminary analysis and descriptive statistics, and I wanted to display the two different ways that I took to evaluating each column. The first was a longer process just because I wanted to have manual breakpoints to see the distributions of the different type of prices, because from reviewing it, it seems that all of the prices are heavily distributed at the lower end, from $200 and under, while it still ranges all the way up to $10,000. So this made sense to me to get a good understanding of how the price is broken down. But secondly, you can see with something that's categorical, like the boroughs, it's much easier to just use the dply or group by function and get the same kind of results. From this exploratory analysis, we see that 48% of the listings are $100 or less, and actually 82% of them are $200 or less. We see too that the listing locations are over 80% in just Brooklyn and Manhattan out of the 5 boroughs. Also, around 2/3 of hosts only have one total listing, whereas the other third of hosts have more than one rental space that they can offer at a given time. And of these nearly 50,000 listings, 35% of them can be assumed to be unavailable since they had a value of 0 in the column for their yearly availability. The last step I took in the preliminary analysis was just to see how it's distributed geographically, where the locations are. Just because it came with the latitude and longitude, I would be remiss to not just give it a glance of it on a map. But this really just confirms what we saw earlier, that 80% of all the listings are in just Manhattan and Brooklyn. So this doesn't give us any new insights and won't be used with the Shiny application for that reason. So on to the association rules mining. There's still 2 steps to clean up the data before we can run the transaction and rule set. I'm going to remove some columns, such as the host and listing identifiers and the numerical latitude and longitude values, just to not confuse the algorithm. And then secondly, discretize the data frame so that the numerical values are changed into categories at different levels that I've set custom at 7, 5, and 3. This will just make them from a numerical value to a set of categories like lowest, lower, low, medium, and so on. For the method to break up the intervals, I use the K-cluster algorithm. I think that will treat the distribution more fairly than an equal interval like we saw when we broke down the prices. So onto the actual association rules mining, I will create the transaction data set and then run the a priori function on that to create the rule set. Here for the parameters we can see I've given some default values because the code itself is set up to allow for the user's interactivity in changing those values when they use the sliders in the Shiny app. With the rule set created, I will move on to the user interface of the Shiny application before the server. Here I set up the sidebar panel where the user has the slider options to change the values of the a priori call. And then for the main panel, I set up all the different tabs for the tables and plots. Next is the server function, which is the majority of the script. It will load, clean, and analyze and plot the data, and it will include the a priori call. And since it's part of the server function, it needs to be within the reactive bracket that we saw earlier so that the Shiny app knows to update it when the user changes any of the settings. This has a downside because it's a reactive expression now, stored in R instead of an association rules object when it's within the reactive bracket. So I cannot filter it or sort it based on a quality like lift. So this will be compensated for with the interactive plots, so it shouldn't make too much of a difference. Still in the server function, the top code chunk is where I define the descriptive statistics that we saw earlier, so that that's available in the Shiny interface as a data table. The second chunk is where I've added the single table for the rules list based on the user's settings, so that they can sort by lift or confidence or the rules themselves and see how and why a visualization is represented that way, and that way everything's in one place. The last code chunk displays the 3 types of plots that will be created to visualize the association rules. With all that set up, we can now launch the Shiny application, and when I do that, I satisfy the parameter display.mode with the value showcase, and all that does is it adds the actual source code for the application at the bottom of the interface in Shiny so that the user can see it and read through all of the code to see why the visualization is this way. So after doing all this work to prepare the data and create this beautiful interface, what are we really going to learn from it? What I've taken advantage of is the interactivity of the support and confidence, and set those high or low to see which kind of rule set will be most beneficial to find something interesting with high lift values. And we can see that having a lower support and a higher confidence will give us more rules with a higher lift. So that is the route that I will be taking to draw any conclusions. With these same settings, I've gone through the interactive interface and found an interesting rule that is supported by the top 5 highest lifts of the rule set. And that is that they're all telling the same story, which is that Brooklyn listings have the lowest price. This is a little bit to be expected because a large number of variables, that the top number of highest lifts are all very similar and kind of pertaining to one message. So I'll go through the remaining rules with significant lift and see what else is interesting here. We can see 3 additional rules here, the one in the visualization being that private rooms in Manhattan are usually listed by hosts with the lowest number of listings in their ownership. So private rooms in Manhattan are usually rented out by people where that's their only listing. They don't have any other rental properties to offer. Also, we see below that the Brooklyn listings with the lowest price are usually private rooms, and the Manhattan listings with a lower price are usually entire homes or apartments. Other than the scatter plot in the Shiny app are 2 other tabs where you can see any possible insights from a parallel coordinates plot on the left or a graph format plot on the right. Both of these, in my opinion, are too busy and convoluted to really read and get a significant understanding of any insights or hidden rules, especially the parallel coordinates plot that, while it does describe support and confidence with the width and color of the arrow, lift itself as a quality is not expressed at all in that graph. So I'll stick to the scatter plot to draw any conclusions. So while the rules that I found interesting were not exactly what I expected, as far as the price being low in all of the rules, and there really not being any rules at all that correlated to a high price, the objectives were nevertheless satisfied. I used association rules mining to construct interactive visuals in Shiny, and found some interesting rules and insights with significant lift values for the dataset. Most notably that private rooms in Brooklyn will likely have the lowest price. Lower price Manhattan offerings will likely be the entire home or apartment as opposed to a private room, and that hosts in Manhattan with private rooms have the lowest number of listings. A few notes on how this analysis might be improved upon would be to have a data set that covers more than a 1-year period to see if there's any changes within those time intervals, because there could be insights there. Secondly, it would be ideal to also do a sentiment analysis on the title of the listings, which I was not able to do, and incorporate into this association rules mining. So for instance, I would be assigning a positive or negative score to the titles like Clean and Quiet Apartment versus Best Bet in Harlem to see if there's any associations there. However, it would be very difficult to guarantee that the sentiment score is accurate just because of how specific this type of text is, being a listing for a rental property. Despite this, the analysis is still important, as it can provide insights to Airbnb hosts, customers, and just the general population living in that given area. For instance, knowing that more than 80% of all Airbnb listings are in Brooklyn and Manhattan, that might change a customer's decision about what airport to arrive at if they can get there quicker. Or knowing that Brooklyn private rooms are usually listed at the lowest price might change how a host's decision is made about what price to list their own rental at. That is my final project, and I hope you enjoyed it as much as I have. Thank you.